Okay, so the second half of this podcast is about the inverse trigonometric relations, not the inverse trigonometric functions. And remember, a relation is the name for a relationship between x and y that can be an equation, a graph, a table, but that isn't a function, right? So in other words, what the inverse relations do is answer the question, what are all the angles that have a particular cosine value? Right? So what are all the angles that have a cosine value of whatever value it is I'm looking for? Um, so I have this unit circle here because it really is going to help us think about what's going. Now remember that this is the u-axis, this is the v-axis, and on the unit circle, the u coordinate, um, is the cosine value of the angle. So if I look at a particular cosine value, let's say I say, where is cosine of theta equal to 1/2, right? I can go along the u-axis to right here. That's about 1/2, right? Because I know it's a unit circle, so the edge of the circle is 1. And there are two places on the circle, this one here and this one here, that have a cosine of 1/2. And therefore, there are two terminal rays I can draw that correspond to angles having a cosine of 1/2. And because this is a unit circle value, I know that this angle here is 60 degrees. And this angle here, oh, I totally screwed this up. Ha ha ha. No, I did not screw this up. Sorry. And this angle here is negative 60 degrees. I totally confused myself. Okay, so this is all fine. These are the two places on the unit circle that have a cosine of 1/2. So is it true, right, that all of the angles in the whole world that have a cosine of 1/2 are 60 and negative 60? No, because each of these terminal rays have an infinite number of coterminal angles, right? That's 60 degrees, but this angle, which is negative 300 degrees, is also an angle that has that terminal ray, as would be 360 plus 60 is 420 plus as many 360s as I want. So there's actually an infinite number of angles that have that terminal ray. I can't write a list with an infinite number of entries in it. So the only way that I can describe all of the angles that have that terminal ray is using a formula. And I talked about this a little bit in class. I don't know if Mr. Gallagher did, but one of the ways that I can write all of the angles with this terminal ray is saying this is 60 plus 360n, where n is a variable that is always an integer. And I get to choose it to be whatever I want, right? So if n is 0, then I get 60 plus 0, which is 60. If n is 7, then I get 60 plus 360 times 7, which would be the angle that corresponds to going around 7 times and then landing there. If n is negative 4, then it would be 60 minus 360 times 4, which would correspond to going around backwards 3 times and then landing there. Does this make sense? I think it does. Great. So this is the equation for all the angles of that top terminal ray. The equation for all the angles here would be negative 60 plus 360 n. So now this is a complicated setup, right? There's not just one, if I say, hey, what are all the angles that have a cosine value of 1/2? There's not an easy answer. And not only that, it's not a short question to ask, right? So we want to figure out a way that we can ask that question, but abbreviate it. And the way we're going to do that is we're going to use the the function, or it's not a function. We are going to use the notation. That's what I'm looking for. Arc cosine. So arc cosine is the way that you pronounce this, not arc cos, right? So if I say arc cosine 1/2, what that means is find me all the angles with a cosine of 1/2. Okay, so in this case, right, it's going to be 60 plus 360n and negative 60 plus 360n. And if I were kind of lazy, which I always am, this is the same thing as plus or minus 60 plus 360n. Okay. Okay, let's do another example using this arc cosine notation. Draw a little wall here, right? What would arc cosine of negative 0.3b. Okay, so first I'm going to draw a picture. And actually, I think what I'm going to do is erase all this stuff here on this picture so I can draw it again. But we're going to use the same drawing. Okay. Arc cosine of negative 0.3. So let's just draw the picture. We're not going to worry about um, uh, anything other than a conceptual picture at this point. So where is cosine equal to negative 0.3? So again, look, this is my u-axis, right? This is my v-axis. Where is u equal to negative 0.3? I don't know if this is negative 1 here, right? So about a third of the way, maybe like here, negative 0.3. And there's two places on the unit circle, here and here, that have a cosine of negative 0.3. Here are my terminal rays that go to those locations. So I know that this angle, whatever it is, and I know it's not obvious what that angle is right now, that has a cosine of negative 0.3. So does this angle, right? So how do I figure out what that angle is? Well, I have to use my calculator, right? My calculator, remember from the first video, right, that inverse cosine, what that'll do is it'll figure out what the one angle is in the principal branch of cosine that has a cosine of whatever value it is I'm looking for. So if I go back to what I was doing here, right? What happens if I do inverse cosine of negative 0.3, right? Well, this is going to give me one angle with a cosine of negative 0.3. Right? And if I have one angle, then I can be clever and use that to figure out all the other ones. So let's pull up a calculator real quick. Okay, here it is. I'm gonna bring it over here so I don't cover up what I'm doing with this. And I'm gonna type in, I'm gonna make sure that I'm in degree mode for right now. Okay, so I'm in degree mode. I'm gonna do inverse cosine of negative 0.3. Super. Okay, so I get 107 point, oh, it's gone, 107.46 degrees. Great. Okay, so that's telling me that this angle here is 107.46 degrees. That seems pretty reasonable. And that tells me then again that all of the angles that have this terminal ray are 107.46 plus 360n, just like it was when we did 1/2. Okay, now this negative one here, right, this is going to be symmetric. I know that it's not coincidence that this angle that I just said was 107 degrees goes to the same place as the negative one does. This is negative 107.46 degrees plus 360n, right? So that tells me that arc cosine of negative 0.3 is plus or minus 107.46 plus 360n. Okay. So in general, arc cosine, and I'm going to say arc cosine of r right now, just to remind you that r is the cosine ratio. The book uses a different variable. I think they use x, but I'm just going to use r to make sure that we all remember that that number is the ratio, right? And we're finding the angles. R cosine of r is equal to plus or minus inverse cosine of r plus 360n. And this is in degrees. In radians, it would just be plus or minus cosine, inverse cosine of r plus 2 pi n. Okay, cosine, inverse cosine. Let's talk about inverse sine. Same idea, okay? The only thing that's different is that sine isn't u, it's v, right? So instead of going to the same place on the u-axis, I'm going to go to the place on the v-axis. So let's say that I want to do arc, I can't write, arc sine, let's do a hard one, of negative 0.8. Okay, negative 0.8. So where is sine equal to negative 0.8? Well, this is negative 1, so negative 0.8 is almost there, right? So there's two places on the unit circle that have a sine of negative 0.8. Here is one angle, here is the other. Okay, now these angles are not, they're not positive and negative like they were for cosine. So sine is just going to be a little bit more awkward than cosine was. Okay, let's try and figure it out. Let's figure out one angle that has a sine of negative zero point 0.8. I'm going to use my calculator. Okay, inverse sine of negative zero point 0.8 is equal to negative 53.1, I think it was. Negative 53 point, yep, 13 degrees. Okay, so that is telling me this angle is negative 53.13 degrees. And therefore, all the points here are negative 53.13 plus 360n. Now, it's harder, I gotta be cleverer, to figure out what one angle having the other terminal ray is, right? I gotta think harder. Now, because of symmetry, I know that this angle here is also negative 53 point, or it's also 53.13 degrees, right? I'm going to say that this is positive because I drew this angle in a positive direction. So if I wanted to figure out another angle, what the angle in standard position going to that point is, if I wanted to figure out, say, that angle, right, I could say that that is 180 plus 53.13 degrees, right? So that ends up being 233.13 degrees plus 360 n, right? So this one, right? I didn't actually finish this. I'm glad I'm going back and editing it. So arc sine of negative zero point 0.8 is negative 53.13 degrees plus 360 n, and 233.13 degrees plus 360 n. Now I can't write that shorter, that in a way that I did for cosine. That's all I got. And in general, I can say that arc sine of a ratio r is equal to inverse sine of r plus 360n. And convince yourself of this, 180 minus inverse sine of r plus 360n. If you don't buy that necessarily yet, I think that as we practice this in class, you will figure it out a little bit more in depth. I want to cut this off now because I don't want to watch this for 45 minutes, but we can do a similar thing for tangent, and we will talk about that in class on Monday. All right, that's all there is.